Hi there. Welcome to Raelene Maths. In this video, I'm going to solve absolute value equations and inequalities. This is a video that's close to my heart because I often see the solving of these equations and inequalities done so as to get an answer without really understanding the process, and there are misconceptions along the way. In fact, when I was a maths program head, I used to hire maths teachers, and I would ask them how to solve this. When they showed me what they would teach students to do, I didn't understand the process. It looked something like this. We'd have to remove the outer function in order to solve, so we would work from the outside in. And I would see teachers write x minus 5 equal to 7, then a vertical line, and then x minus 5 equals negative 7. Then when we would solve each of the two linear equations, we'd get x equals 12 over here and x equals negative 2 over here, but this vertical line wasn't really clear. Did it mean and or? If we understand what the answer is, then we know which one to choose. It turns out that this is coincidentally correct, as long as we choose the or between here. The solution actually is x is equal to negative 2 or 12, which could lead to the misconception that this vertical line means or. But when we take a look at applying this approach, if you will, to an inequality like number 2 or 3, we get into some problems. If we do the same thing and say x minus 5 is greater than 7, vertical line, then x minus 5 greater than negative 7, we end up with two statements, one that says x is greater than 12, and the second says x is greater than negative 2. If we choose or again here, this doesn't really make sense. X is greater than 12 or x is greater than negative 2. We would only need the x is greater than negative 2 to satisfy this. And it turns out that this method is incorrect. So we memorize what to do, that we actually have to flip the second inequality over here. And we're not really explained why, we're just told that's what you do to get the answer. And so we get a statement that says x is greater than 12 or x is less than negative 2. But the or is only valid in this case, and for the less than case we use and. To me it all just seems, well, contrived. So I'd like to go back to the basics to remember what some things about absolute value have to do with this and build from there. So the first thing is that distance in one dimension can be represented by the absolute value. For example, the distance between x and 5 is expressed as the absolute value of x minus 5. And furthermore, the distance between 5 and x is represented as the absolute value of 5 minus x. And of course, the distance between x and 5 and between 5 and x is the same. So those two absolute value expressions are equal to each other. Another truth is that we can express absolute value as a piecewise function. And so what that means is, if you take the absolute value of some stuff, and if that stuff is positive or 0, then the absolute value of that stuff doesn't change the value. But if the stuff is negative and we take the absolute value, then the job or the role of the absolute value is to change the sign of the stuff. We write that in piecewise notation with this curly bracket with two different lines depending on whether the input stuff is negative or if the input stuff is non-negative. So what does that mean for us? In the first example, when we see something like the absolute value of x minus 5 equal to 7, we can express this verbally as the distance between x and 5 is 7 spaces. And I like to reword that slightly differently so that we can look at it from the point of view of x. In other words, we know that x is 7 spaces away from 5. And we know that absolute value is one-dimensional distance. And so here we have that the 7 is a distance and the 5 is some kind of center. And so if we happen to be on a number line, an x-axis, and the 5 is some center, we want x to be 7 spaces away from that. And we only have two options to go in one dimension. We could go to the right of 5 or to the left of 5 by 7 spaces. Now I know I said that distance is one dimension, but I'm actually going to draw a circle because I really like the visual of the circle and I like to be able to extend into 2 dimensions for distance. In this case then, my distance is the same as the radius of the circle. So the distance or the radius is equal to 7. And so if we go 7 spaces to the right, that takes us to an x value, which is 5 plus 7. In other words, 12. However, if we go 7 spaces to the left, we get to a second x-coordinate which could satisfy this statement, which is 5 minus 7, which is equal to -2. And from here we can see that our solution is going to be x equals -2 or 12. Now we did get that with the first algebraic solving, but it wasn't really clear and it didn't extend to the next case for the absolute value. So let's use this verbal interpretation in the second question. Here this says that the distance between x and 5 is more than 7 spaces. And so we can read that from the point of view of x, which is to say x is more than 7 spaces away from 5. So on our number line, we could still look at a center of 5. We could look at a circle of radius 7. I'm going to move my circle over a little bit. My circle of radius 7 here still tells me that if I were an x-coordinate on the boundary of the circle, on the circumference, x would either be -2 or 12. I'm not going to put a solid point there. But in this statement here, we want x should be or is more than 7 spaces from 5. And so this is suggesting that x can either be on the circle, inside the circle, or outside the circle on the x-axis. And in order to be more than 7 spaces away from 5, the center, x needs to be not equal to 12 or equal to -2, but on the outsides like this. And so when we go back to our set notation and understanding how to write this one-dimensional set, we get the solution that x is any point that's over here in blue or over here, so x is less than -2 or 12 is less than x. Of course, we can write that second set as x is greater than 12. Now, if you memorize the solution from earlier, you will get the right thing, but at least here we have a visual geometric interpretation which is consistent with what we did in the equation case. In the equation case, x needs to be exactly 7 spaces away from the center, and in this inequality, x is to be more than or beyond 7 spaces away, so outside of the circle. So you can pause the video and try this next one on your own by thinking verbally and interpreting this inequality statement in one dimension. Okay, so what it really says is that the distance between x and 5 is less than or exactly equal to 7 spaces. And from the point of view of x, this means that x is, I'll put therefore, x is less than or exactly 7 spaces from the center of 5. So on our number line, which is the x-axis, we are going to have a circle, and the radius of that circle is going to be 7. We have a center at 5, and we could go exactly 7 spaces to the left or to the right of the center along the x-axis. Now, our question is asking us to find the x values that are less than 7 spaces from 5 or exactly 7 spaces from 5. So to be exactly 7 spaces from 5, x could either be at -2 or 12 again, because we do have an equation here. But we also want x to be any point on the number line which is less than 7 spaces away, meaning inside the circle. And so here we end up getting a solution that says x is any point in red which happens to lie in between the -2 and the 12. So -2 is less than or equal to x, which is less than or equal to 12. Coincidentally, this is a compound inequality, and if we were to separate that compound inequality, it would say -2 is less than or equal to x, and x is less than or equal to 12. So in the case that we were taking the two absolute value statements and breaking it apart with a vertical line, in this case, the vertical line is representing and not or, like we saw in the previous cases. I've spent a lot of time now talking about this blue information, how absolute value represents distance in one dimension, but I haven't touched much on this red information that we can use piecewise notation to express absolute value. So I'm going to refer back to this in finding out what exactly went wrong in the traditional common approach for solving absolute value equations. We notice that it's not the outside of the absolute value, the 7, which gets changed by plus or minus, but rather the inside stuff. Here we see that this x minus 5 is the stuff that is either multiplied by positive 1 or negative 1, depending on the sign of the stuff inside. So if we were to modify this and say that we're taking x minus 5 and either multiplying by plus or minus 1, instead of the 7, which is getting multiplied by plus or minus 1, then we would have a better shot at success. This would still give us that negative times x minus 5 equals 7, or positive times x minus 5 equals 7, which gives us x minus 5 equals negative 7, or x minus 5 equals 7. And from here we get the same answers of negative 2 or 12. The impact really comes along if we have an inequality symbol here. So if we took the second question, which was x minus 5 in absolute value greater than 7, we would see now that removing the absolute value symbols is impacted by putting plus or minus around the stuff and not around the 7, as is typically done. We still have a problem here, and I didn't address it here, as to how we get and or, but without that, at least we're getting the right sign change for the inequality that we were just memorizing in the previous explanation. So here, if we want to multiply through by negative, we would have to flip the inequality symbol. Of course, that's because we're really thinking of adding terms to both sides of the inequality, keeping the inequality fixed, and getting a negative 7 on the left and positive x minus 5 on the right. Either way, we're getting that negative 2 is greater than x. In other words, x is less than negative 2, and from the other side we're going to get that x is greater than 12. Again, it still begs the question, do we have and versus or? And I don't think that this approach really handles it very well. I do like the one-dimensional graphical or geometric approach, and I'm going to show you another approach using two-dimensional graphing in the next video. If you like the video, click like and subscribe to my channel. Stay tuned for more on solving absolute value equations and inequalities. Thanks for checking out Raelene Maths.